Hi, Alan Stratton from Woodturning. Recently reread a book by Dill on multi-axis turning. Looked through the glossary and it had one that looked kind of like this, which was essentially a sphere that we've had several times on my video program. But in this case, we go the extra on that and in effect bore random holes on the outside. And so they were talking about how many different axes it took. So this is 1, 2, 3, 4, 5, 6 axes. But remember, when we turn a sphere, we're probably using 10 different spindle turning axes to get the sphere made. So 16 to 20, who knows how many axes were actually used in making this sphere. I lost track. But key to making this is a donut chuck, similar to this one. This is on a faceplate. I had to mount a little cup area here in the middle to be able to seat the ball into, and then another panel goes on top and through the holes and cinches it down. The thing that makes this really work well is this vinyl tubing that's split and put around the opening, which is a very nice cushion for this task. So donut chuck, shop made, piece of cake. However, the turning is not exactly a piece of cake of these things. It gets pretty wild and woolly when you're going into deep and intersecting another hole. But let's go ahead and make this multi-axis ball. I'm not sure what to title it, but it is a multi-axis ball.
For this project, I'm starting with a big block of Titan cedar harvested from a tree in my yard in Oregon. A block this big is awkward and very unbalanced. I'm going at it with my bowl gouge at slow speed until the corners go away. With the wood now round, it's time for a few calculations for the octagon that will contain my sphere. 0.293 times the diameter for the distance from the top to the first corner, and 0.414 times the diameter for the size of the face. I'm marking these lines in the middle of the sphere. Now to turn down the end spindles to the size of the top face. Actually, all that I need is a mark, but a spindle works for me. Now it is easy enough to cut a 45-degree taper from the corner of the spindle to the top line, both top and bottom. Now to reduce the end spindles to half the diameter of the face. While this is all waste wood, it helps me visualize the next step. Now I can mark the middle of the corner flats. I already have the middle of the side face marked. This guides me to be able to make the octagon into a 16agon, or whatever that is. Actually, I just go ahead to round off between the lines and make the overall curve. Now that I've cut off the spindles, I can swap out the centers for cup chucks for both the top and the bottom. As I try to seat the sphere, I worry that my sphere is not that spherical. Still, the task is the same. Cut off the ghost and leave the previous equator line. Now I'm sure It wasn't quite spherical. Now for a quick rotation. It's pretty bad. You'll have to watch my video on turning a perfect sphere because I'm cutting corners this time, and it is taking longer. Another rotation, which puts me back to about where the first one. My sphere is seating better in the cup chuck. Apparently, I cut the one end somewhat short. I'm having to cut away more wood than I expected. In the end, I cut away about 1/4 inch from the diameter. Another rotation, much closer now. Another rotation, I'm definitely in overtime now. Now that it is a sphere, I can power sand the ball. This goes nicely for a sphere this size, 80 grit to finish the rounding and finish 2 with 400 grit. As usual, it is 3 rotations per grit. Now for random holes. I've mounted the doughnut chuck on the lathe. The doughnut base has a dowel to mark center. I put a piece of scrap on the dowel, fastened with hot melt glue, and dished it out into a cup to receive the sphere. Then put the top plate with the vinyl tubing and cinch it up with the 3 pieces of all thread. I'm cutting this hole with my bowl gouge. It's kinda scary due to vibration in the doughnut chuck. This is definitely not as solid as a typical compact turning that would be closer to the chuck and spindle. I switched to a round carbide, but the cutter is probably too big of diameter and dull. It is not cutting well, so back to the gouge. I try a heavy scraper. Finally, sand it up through the grits, carefully by hand. Now, loosen the bolts and rotate the sphere to a new position. I'm going to drill this one with a Forstner bit, but drilling is not enough. I'm making it larger and somewhat tapered with my bowl gouge. I try the scraper and the carbide again. Now that there is an intersecting hole, hollowing is getting rough. Then sand it, since I'll never be able to get back to exactly this same axis again. Again, loosen the bolts and move the sphere to yet another location. I'm sticking to the bowl gouge this time. A trip to the opposite side of the lathe helps to control the gouge. I tried to touch it up with the carbide tool, then sand this hole. I'm going at another position again with the Forstner bit to start with. Then enlarge the hole again with the bowl gouge from the opposite side of the lathe. The intersecting holes inside make the going tough, but I'm getting used to it. Now for another. This is getting easier, but there are more rough corners on the inside. Drilling is a bit easier to handle the inside corners, but still enlarge the hole. I don't have to go larger very deep because it is somewhat hollow already. I think this one will be the last one, at least for this project. I've settled on the drill and the gouge as the best options for me. Finally, a bath in walnut oil brightens up the wood. Multi-axis turning is fun, but also difficult. This project is definitely not for a beginner and not even a frequent project for a more experienced turner. Yet it is an experience that will lead to greater experiences. Please give this video a thumbs up, subscribe on my website, tell your friends, and send me your comments and questions. Every week I make a new wood turning video. Please wear your full face shield anytime the lathe is running. Until next week's video, this is Alan Stratton from As Wood Turns.